Okay, so the homework that was due last night, you had a high degree of success. We don't need to talk about any of those problems, but let's just review quickly. We talked about the three ways we could group quantitative data, right? Quantitative data is when our data values are numbers, values, and we said that there was two kinds of quantitative data. What were the two kinds of quantitative data?
Discrete and continuous.
She said discrete and continuous. Agree with that? And discrete means what? What's that? Yeah, you could list them, right? So it's like distinct values, right? Usually we're talking about whole numbers. So usually when you talk about discrete variable, you're talking about like 1, 2, 3, 4. And then continuous is when you have like a continuous range of values that you could never list, right? Because like it's like, you know, you could have 3.1, 3.15, 3.16, 3.162, you know, it's like with decimals you could have any continuous value in between ranges. Okay, so single value, yeah.
Would continuous always be contain a decimal, or?
Yeah, so it would have to include any number of decimal places. Because if it doesn't have decimal places, then you're just talking about whole numbers, and that's discrete,
Okay.
right? That's what makes it continuous. Is like you could keep slicing it thinner and thinner, and you know you could, like if you had any two values, you could always find one in between those two, no matter how far you kept going. All right, so the first one was the single value grouping, and that was for discrete variable, and the groups were based on each particular data value. And then the limit grouping, it was also for discrete, remember, it's discrete, but we put things in ranges. And then the last one was the cut point grouping, which is for continuous, where we have to put things in ranges, right? We absolutely have to put them in ranges. And so those were our three ways of organizing quantitative data in a table, right, in a frequency table. We have to decide if we're going to do single value grouping, limit grouping, or cut point grouping. Okay, so we're going to talk about some other ways to organize data. The next one is what's called a dot plot. Dot plots are really easy. Just like the frequency distribution tables, you have, or just like a histogram, you have the value of the variable on a horizontal scale, right? So this is the value. This is prices of DVD players. They found 16 DVD players and found their prices, and this is obviously out of date, right? DVD players have come down in price a lot, right? So this may be from 4 or 5 years ago or something, or even more. But anyway, so the value of the variable, the price of the DVD player, is on the horizontal axis, just like in our histograms, right? Just like in our histograms. And then every time, so then you take your data values and you just put a dot. So this first one's for $210. You just put a dot for 210, and then 219. Put a dot. That means that one of the DVD players costs 219. 214. 197. 224. 219 again. I'm going to stack it up here. So this is the second one that's 219. So I'm going to stack it right above it. 199. Another 199. 208. 209. 215. 199. 212. Another 212. Another 219. And a 210. So that would be this is the dot plot for this set of data. And so how is this like a histogram? So this is similar to a histogram. How does it resemble a histogram? Yeah.
Basically a histogram with dots instead of bars.
Right. So the height. So you instead of bars, you get a column of dots, and the higher the column goes of dots, the higher the frequency. Right. Just like in the bars. So again, you've got frequency going up and down, and the continuing the value of your variable across horizontally. So then it's just a variation on a histogram, basically. It's a variation on a histogram. Let's see, how did I do? That's a prettier version, okay? But in order to see it properly, so all the first data values of a particular, all the first dots of a particular data value have to be in line, and all the second dots have to be in a horizontal line, and all the third dots have to be a horizontal line, so you can see relatively what the distribution looks like. Okay, questions on dot plots? Pretty easy. Okay, the next one is called a stem and leaf plot. Okay, so what a stem and leaf plot is here's our data, and what they're doing here is we have what's called the stem, and in this case, the stem is the tens place on our data. So this 3 right here refers to what? 30. And so then this 8 right here refers to what? 38. It's showing that there's one data value in here. One of our data values was 38. So this 3 applies to the 6, the 8, and the 9. There was one investment had 36 days to maturity, one had 38, one had 39. So let's find those. So here's the 38. There's the 39. And there's the 36. So that's where they're showing up right there. 36, 38, 39. Okay, so what do these 3 zeros mean right here?
70.
It means there were 3 data values of 70. Let's find them. There's 1, there's 2, and there's 3. Okay, so notice in order to construct it, if you're going to put your stem, and then just to get started, you can just go through the list and just write the numbers down in this kind of intermediate step, and then you can get the numbers in order from least to greatest. So here in the 50s, they've gone through, and the first one they came to say was 57, and then 51, 56, 53, etc. And then in the final step, got those in from least to greatest in the 50s, right? 50, 51, 51, 53, 55, 55, 56, 57. Okay, so we're going to make a stem and leaf plot for our class right here. We're going to do our heights in inches, okay? We're going to do our heights, in centimeters. So here's how you find your height in centimeters. So we'll do my height together. So I'm 6'5". So first we want to get inches. How do I get inches? Take the 6 feet and multiply by 12. So when I multiply by 12, I get 72. That's 72 inches for my 6 feet. And then I got 5 inches, 77. And then to get centimeters, you're gonna take that and multiply by 2.5. There's approximately 2.5 centimeters per inch. So we're going to take 2.5. As soon as somebody gets that, tell me what it is. Someone else get that? Yes. Confirm. And then I'm going to round that up to the nearest centimeter. Okay, so what are we going to do? So our stems are going to be, the stem is going to be this. right? So the stem is always going to be all the numbers except the last one, right? Except the last one. And then this would be the particular leaf for mine. So everyone find your height in centimeters. You're going to multiply your feet by 12, add that additional number of inches, multiply by 2.5, and round the result. So you take a minute to do that, and then we'll go around and we'll get all our heights in centimeters. Okay, go. Everyone's getting your height in centimeters. Everyone got a calculator? All right, here we go. So heights in centimeters of so mine was I already forgot. What was it? 193? Okay, here we go. 153? 163? 163? You're all gonna end in 3? 163? 160? 150? 180? In the back? 165? 173? 155? 170? 180? Should have done 2.54. 158? 173? 145? 163. Okay, so can we make the stem and leaf plot? So what's our first stem going to be? 14, okay? So we're going to have 14, 15, 16, 18, and 19. Okay, and then you draw the bar. And then we're going to put the leaves on. So what do we got? Just one in the 140s? And then the 150s. So there's a 3, a 0, and a 5. Any more 150s? An 8. So 0, 3, 5, and 8. So let's cross these out when we get them. So we got the 150, or what? 150, 5, 53, 145, 158. That's 5, right? Okay. 60 in the 160s. How many? So we got a 160, and then 1, 2, 3, 4, 4 threes. 5 threes or 4 threes? Just 4, and then a 5. Any more? Okay, so now I didn't do. You want to keep things in line vertically, and I'll show you why in a second. So we want to keep an equal space this way, so you keep all your first leaves in a vertical line, all your second leaves in a vertical line. Okay, so keep the spacing the same as you go from left to right. Okay, the 170s. So let's get rid of these here. So we get the one. Okay, 170s. A 0 and 2 threes. Anything else? Okay, and so that's 0, 2 threes. 18, 2 zeros, and then 3. Okay, make sense? Okay, and so then it's not really, you wouldn't really do it in this case, but there's something else you can do. If you have lots and lots of leaves, so we'll do it for this one, but it's probably not, it wouldn't be really appropriate for this one, but we'll do it because you're gonna have to do one. If there were lots of leaves, what could we do? How could we break this down further? Well, we could take each stem and leaf and then we could split it into leaves from 0 to 4 and 5 to 9. So we'll just do that for this one, although it's kind of not appropriate, but just to see what's going on. So we'd have 14. So when we do this now, we're going to have 2 14s, 2 15s, 2 16s, 2 17s, 2 18s, and 1 19. That's all we need, and I'm out of space. Okay? So the 2 14s would be, you'd have 0 to 4, we don't have any, and then 5 to 9. We put the 5 here. And then for the 15s, 0 to 4, 0 and 3, and then starting at 5 and 8, that. 16, 0, 3, 3, 3, 3, and 16, 5. 17, 0, 3, 3. This 17 wouldn't have any because these would be the 175 through 179. Then 18, 0, and 0. And then down here, 19, 3. So this is a different way to do this, and it would be more appropriate if there were lots and lots of leaves on each one of these. It would make sense to do this. So this is okay, but not really necessary. Yeah.
Would it be appropriate to leave off like the second 14 and
yeah, at the top.
Second 17 and the second 18 since there's
no, you don't want to do that.
You don't want to do that?
And we'll see later in class why. Because this is still giving us a visual of the distribution, and you're changing. You want to keep that scale, the scale for the variable. You want to keep that even, right? If you take the ones out that don't have any data, then it's like you're making a number line like this. So imagine if you did a number line like this. You did 0, 1, 2, 3, 4. 5, 6. It kind of has that effect of pulling, you're pulling your data values out of whack, and so then the visual gets messed up. But we'll talk about that later in class. Okay, so I want to snapshots of these. Okay, so now your turn. You guys are going to do some for some credit here. So you're going to work on this. This is cholesterol levels for 20 high-level patients. You do it 2 ways: the 1 line per stem and the 2 lines per stem, just like we just did. Pass back. Oh, I'm sorry. When you work on these to turn in, always work this way. Don't work this way. Work like a little sheet of paper, up and down, and then you're gonna write just name and date. Upper right-hand corner. Put your name. That's where your heading's gonna go. Upper right-hand corner, this way, up and down. So name and date, please. Okay, we're going to do these every day in class, and you're always welcome to work together unless I say otherwise. So you're welcome to check your work, collaborate. You're making two, right? You're making the 1 line per stem and then the 2 lines per stem. Yeah. You're making 2 stem and leaf plots. One with 1 line per stem and one with 2 lines per stem.
Yeah, but do you want them like in order from least to greatest? Both of them?
Is that what a stem and leaf plot is? Yeah.
Are you always going to split it when you have the 2 lines per stem, like evenly, like right at 5?
Yeah.
Okay.
Yeah, so it goes 0 to 4, 5 to 9. Yep. Okay, just a couple more minutes. We'll move on. Okay, it looks like everyone's done. Okay, so we're going to talk about, so there's something that all these, they all have in common. So that the histograms, the dot plots, the stem and leaf plots, all have something in common, and that's they all show what we're going to call the shape of the distribution of the data. The shape of the distribution of the data. This is huge, okay? This is huge in statistics. So a distribution of a data set is any visual or anything that provides the values of the observation and how often they occur. So this is the key. The values of the observation or the data values and how often they occur. So in histograms, where do we see the values of the observations? Where do we see the values of the observation in a histogram? Horizontal axis, right? Horizontal axis from least to greatest. So from left to right, we see, let's go back. So here was that the days of maturity. From left to right, here's 0 to 100. We see the values of the observations. And where do we see the frequency with which each of those observations occurs? vertically, like how high up the thing goes. The higher up it goes, the higher the frequency of that data value. And so then we get a picture of going from left to right as the data values increase. What's the frequency as you sweep through those data values? Of, how does the frequency change? What does it look like? Okay, so do we see that same kind of thing in where is it? In a dot plot. Where do we see the values of the observations? Horizontal, same thing. And where do we see the frequency? Going up. So it's really the same. What about our stem and leaf plots? So let's go, let's look at this. What about our stem and leaf plots? Right, so look, if I took a stem and leaf plot and I turned it this way, do you see it's the same thing again? So this was the days to maturity. So here's the stem and leaf plot for that. And here's the histogram for the same data. What do you see? So here's the stem and leaf plot for the investments days to maturity. Here's the histogram for the investment days to maturity. What do you see? Do you see it's the same? Can you see the same exact shape? As the data values increase this way from whatever 36 up to 99, from 36 up to 99, we see we've got this higher bar here, then a low bar, then it goes up, and this is called our mode. This is called our mode. It's the most frequent place in the most frequent value, or in this case, range of values. And then a couple even, and then down a little bit, right? So it matches exactly. So the stem and leaf is also showing the distribution is just turned 90 degrees. So if you turn it 90 degrees, it looks just like a histogram or a dot plot. Okay. All right, so there are a lot of shapes that then show up. So when we look at these different shapes, again, we're talking horizontally, values of the data, starting from least to greatest. Up and down, the height of the curve then is the frequency. All right, so lots and lots of data sets have a bell-shaped distribution, especially when you have a big sample or a big population. It's often bell-shaped. Like height, or like here, yeah, here's an example of bell shape. So this is heights. I guess it's just heights of people, right? Heights of people has a bell-shaped curve if you have a big enough data set. And what does a bell-shaped curve mean? It means low heights occur less frequently, and then there's a range of heights that has a high frequency, and then big heights, again, less frequent. That's a bell shape. Okay, and then we have triangular, uniform means same frequency for all data values, right? Same frequency for all data values, that's uniform. Okay, reverse J-shaped. So then these two, so bell-shaped is going to be important for us. Right skewed and left skewed. Is a question?
Are you recording?
Oh yeah. It'd be too late now. You got to ask me at the beginning of class. Okay. All right. So right skewed and left skewed. So, but look. So why is this called right skewed when the frequent? It's like the most frequent values are to the left. It seems backwards, right? Does anyone know why we call that right skewed? When most of the frequency of the data values is really it's on the left. Anyone know? Yeah.
I don't know if this is correct, but it's like the mode is on the left side,
Right.
But it's skewed because like half the values are very low.
Okay, yeah, he's got the right idea. So by mode we mean like where the highest frequency. Okay, mode is highest frequency. So he's right. The mode is here toward the left, but because of all these these high data values that are over here, it pulls the mean up. They pull the average up to the right. So if it's not skewed, the mode and the average are the same. Like this bell shape. The mode and the average are the same. Here, the mode is here, but where's the average? Where is it? To the right or left of the mode? You've got all this data value pulling on the average, pulling it up, pulling it to the right. So by right skewed, we mean the average is skewed to the right from the mode. Does that make sense? That's an important idea. So similarly, left skewed. Bimodal then would mean there's two places where you have highest frequency. Multimodal, lots of places of high frequency. So if you go back to the thinking about multimodal, we had an example of that. That was our dot plot. This dot plot, you would say, is multimodal. Multimodal. You got like a mode down here around 200. You kind of have a little mode here around 212. And you have a mode around 220. Right? So if we got more DVD players, so the way it looks now, it's kind of like this. 3 humps, right? So 3 places of concentrated higher frequency means just beat it. Like trimodal, 3 modes. Okay, so let's practice here. So this is number of TVs. Right skewed, bell shaped, or left skewed? Right skewed, bell shaped, or left skewed? Right skewed. The mode is here at 1, but all this data up here, 5 and 6 and 4, is pulling the average to the right. So it's right skewed. All right. What about so I wanted to do our heights. So here was our heights. So if it helps to turn it on its side, there's our height that we did today. Right skewed, uniform, or left skewed? Or sorry, not uniform, bell shaped. Pretty much bell shaped. A little bit what? A little bit right skewed because of your teacher, right? Your teacher makes it right skewed. Okay, so he's way up here at 193, and without your teacher, it's almost bell shaped. Okay, but your teacher is making it a little bit right skewed. Lots of right skewed examples here. Everything's right skewed, but you get the idea. Okay, that's it. So make sure your name and date, upper right hand corner. This is attendance, right? Attendance and points. Be like low pressure quiz every day in class. And then I won't see you until so then there's going to be there's my math lab going to be due Tuesday night before the next time I see you. We don't have class Monday. And then I'm going to post on Blackboard like a take-home quiz for the long weekend. It'll just be on the stuff we've done so far. Should be easy. Okay? So, my math lab and written work due Wednesday. Okay? Have a good break.